Hi, my name is Josh Spear. I'm with the Coherence Report. I'm a former D-Wave insider, and I've spent more than a decade of experience in the AI and quantum computing space. And I'm here today because there's a lot of confusion about what D-Wave's quantum annealer can and cannot solve. And it's understandable because the company makes it sound like it solves everything. When I worked at the company, the sales department spent a lot of time hiding why their technology was so useless. And one of the reasons why I left the company was because I spent time learning how everything works and quickly realized that the company really has nothing to sell. So this video is going to spend a few minutes diving into exactly what I learned. We're going to talk about exactly what their machine solves. And by the way, it's not optimization. And then we're going to talk about why the market is actually so much thinner than what is advertised. So let's talk about what the annealer does. And by the way, for those who are new to D-Wave, when I mention the annealer, what I'm talking about is their quantum computer, the original quantum computer technology. So there's two technologies that D-Wave pursues. The first is gate model. That's what they acquired from quantum circuits last year. And then you have the quantum annealer, and that's their original technology going back 25 years. For this conversation, we're only going to talk today about the quantum annealer, although technically at this point, their gate model is just as useless as the annealer, but that's another discussion for another time. The annealer is treated as sort of an anomaly in the quantum computing world, and most scientists don't actually consider it what you call quantum computing. That's actually a philosophical debate. I'm not going to get into it here. Just understand it's not considered to be, their annealer is not considered to be quantum because it just doesn't solve the same factoring problems that a gate model would. It's far more specialized. It only solves optimization problems. So if you're interested in explanation on the quantum physics of how the annealer works versus gate model, just look at our website for a detailed explanation. It's really interesting because on paper, these things are perfectly suited for optimization problems because the physics itself matches the optimization math. And so, from a scientific point of view, it's really interesting how this thing works. I do recommend reading the article that we wrote on it. For today, though, we're only going to focus our attention on the total addressable market for quantum annealing. It's not what you've been told. Now, yes, I will agree, optimization problems are everywhere. Every single business should be running their machine because every single business has an optimization problem. But the reality is that almost no one has an optimization problem that should be run on a quantum annealer. So if you're curious about optimization in business, what we're talking about here is the challenge of finding the best possible solution along a long list of possible solutions. So here's some examples that might come up in business. All of these are optimization. So you have scheduling nurses at a hospital. You have delivering packages with limited gas usage. You have stocking a shelf at the local Target. Here's one that's got current events, figuring out how to get ships through the Strait of Hormuz. That is an optimization problem. You have staffing a call center. You can literally find optimizations in every single business. And actually, if you think about it, you can actually find optimization problems in your own personal life. So if there's optimization problems all over the place, then why is nobody using D-Wave's technology? When you dig into the organic revenue numbers for the past 2 years, you see that there's essentially zero revenue growth. And the reason for that is because they sell a proof of concept. That proof of concept goes nowhere. And then because D-Wave's quantum hardware is useless, their flat revenue growth goes nowheres. And so what you see is the growth, the flat revenue growth, it's not an access problem. It's actually a value problem. And look, it's not just the numbers. D-Wave isn't even pretending anymore to have growth in use cases. If you actually read our report, we document how Qubits 2026 was one of the saddest events they had in years. One of the only commercial use cases that they could show was BASF. Great company, great naming brand. That company cared so little about D-Wave that they wouldn't even send a representative to present. This was also documented, by the way, in Kerrisdale's 2025 report, where they interviewed D-Wave's own customers across logistics, manufacturing, and pharma. And the verdict is that there was zero benefit from the technology. And so no matter what the company says in press releases, the quantum annealer, it does not work on most optimization problems. In fact, if you track exactly what the quantum annealer does, it's only capable of working on a very small fraction of real-world problems. So for today, I'm gonna explain what that means. We're gonna take a sidebar here. I'm gonna get into the technical weeds. All right, so bear with me here. The D-wave annealer, it only solves what's called a discrete choice problem. Okay, so discrete for all the non-mathematicians here, it means that your choices come from a finite set of options instead of real numbers. The analogy here is think about the colors of a rainbow. Discrete colors would be red, green, orange, or yellow, but in real life, there is an infinite number of colors like reddish orange or greenish blue. And so in the math world, a discrete number would be 4, 5, 6, but a real number is going to be 4.2, 5.3, anything in between those integers that I gave you before. This is really important when thinking about optimization problems because in real life, the problems can either be discrete or real life. They could be either discrete or real life numbers. Discrete for an optimization problem would be, should I send a package on truck A, truck B, truck C? But a real life number is going to be how many miles can we drive? How many miles per gallon are we getting? How long will the trip take? And so if you think about it, it's really logical to assume that all real world optimization problems have continuous variables because you always want to measure something in the real world numbers. Even if you design the overall problem to be discrete, which means that almost all the real world optimization problems, it cannot be solved using D-Wave's machine. Now, to be clear, yes, okay, I do want to cover myself here. Yes, technically there is a way to manipulate real numbers on their quantum processor by converting it to a discrete, but it's not practical. It has outrageous overhead when you do that. Nor does D-Wave's own internal teams recommend it. All right. So, and we have quotes to show you that. Here's what makes this hard to ignore is that in 2022, D-Wave announced a continuous variable support as brand new capability. So in that time, their exact words were that they were, quote unquote, unlocking a new class of problems. And you see the quotes here on the screen saying that. 3 years later, a peer-reviewed study published in Nature tested that exact same claim. And what they found was that continuous variables were still being routed to classical computers because the solver, the hybrid solver, which we'll talk in a minute, the solver knows that the quantum annealer does not provide any advantage on those kind of problems. As it happens a lot with this company, a release capability actually falls flat and does not work as announced. You see that as a recurring pattern over and over with D-Wave. But the greatest limitation with the quantum annealer is how most real-world problems are just too large for the annealer. And that's in terms of how many variables can be analyzed at the same time. Now, D-Wave's response to this is that they want you to use what's called the nonlinear hybrid solver. Sometimes they abbreviate it as NL solver. And the reason why this is called a hybrid is because it combines quantum computing with classical. That extends the problem size to millions of variables, at least on paper, that is. There are numerous issues with the hybrid solver, and we're not going to go into long details here, but I just want to summarize here some of the issues that come in with NL solver. The first one is that everything needs to be converted to something called a QBO. It's a QBO format. This is QBO. It's a really boring topic, so I'm not going to go into it here. But QBO is a very narrow, rarely used mathematical format. And essentially, the long and short of it is that what that means is that in order to use this, it requires expensive and rare people to make the NL solver usable for a business. Second is that there's no documentation. They absolutely refuse to document how NL problems are actually solved. And this is a serious issue for government and academics. Frankly, anyone that wants to prove that the solver works better than other optimization methods run into a wall all the time because they don't document it. I have an interesting story. If you read my report, I have an interesting story where I actually sat in on meetings where, I won't get into it, but you can actually read in the report more about this. The third is that it's just really slow. Okay, so the primary issue with the hybrid solver is that it really falls short of other solutions that are out there. And look, the thing you have to understand is there's a lot of competition out there. There's Gurobi, there's CPLEX. These solvers are not new. They've been around for decades. And when you actually read the academic literature, there's for almost every real world scenario, Gurobi and CPLEX are faster, they're more accurate, and they're more reliable. So there's no advantage to using D-Wave solver versus stuff that's been out there for decades. Also, you really need to understand that D-Wave's hybrid solver has almost nothing to do with quantum computing. There's really only a tiny fraction of the analysis that's actually peeled off to the quantum annealer to begin with. And by the way, someone who has seen their sales pitches, I can tell you straight up, they're lying to customers because their positioning statement is that the QPU can handle massive problems all at once. But really all it does is it peels off a small cluster of about 30 or so variables at a time. It hands it to the QPU and then it tries to solve it. And because that problem just takes so much time to respond, the non-quantum solver just solves it by itself. The classical compute is what we call it. It just solves it by itself with no quantum involvement at all. And so, D-Wave admits this to themselves. You can actually read it for yourself in their, what limited documentation they do provide. You can read about it here. They're honest and straightforward about it. In fact, even D-Wave's own blog admits that Gurobi is better. And, a peer-reviewed study in Nature Scientific Reports, it actually confirmed the same thing for complex problems. Essentially, what they say is that the hybrid solver is competitive for very simple problems, but it actually falls behind with the exact kind of problems that D-Wave tells its investors that it solves. So what this means is that not only is there strong competition for the NL solver, but that the quantum computing component, it actually makes optimization problems worse, not better. And the only thing that the quantum component actually does is it makes the system sound more interesting for non-scientists, more interesting for investors, because instead of selling an overpriced solver, now they can claim it's quantum. And so essentially, when you think about it, the quantum is really nothing more than a marketing angle. And if you track how much of the analysis is done in NL solver using the quantum processing unit, it's completely insignificant. And there's some quotes here that prove that. Now, if you look at the breakdown of the technical problems with the quantum annealer, you can look at this in the context of a real-world problem. You see that the annealer is useless for enterprise and most government problems. That's why customers aren't buying this, and that's why the company isn't growing. Okay, so here's a real-world example to understand just how useless D-Wave's technology really is. Let's pretend that you are a supply chain manager at Delta Airlines, and you're deciding, if you want to use D-Wave's quantum annealer to solve your very expensive, very important problem, which is optimizing the flight schedule for a day. Let's go through exactly why this won't work. First, the scheduler can't incorporate any real number like miles or time as a decision variable. We already talked about why, right? It can only do certain variables like flights or gates or certain rules like FAA rest rules because it can only use discrete variables. Now, you can also use something that's binary, which is perfect, right? We can find a use for that, but that takes up a lot of space in the quantum processing unit. Next, what we're going to do is we're going to take the problem. We're going to define, we define the problem. Now we're going to take it and we're going to convert it into our complex equation. Remember the QBO, right? Now, because it's a QBO, because it's a rare equation, what we're going to need is we're going to need to go out and hire people who know exactly how to do this, consultants, right? And those consultants are not cheap and they're not easy to find, but we're going to go out and hire them anyways. Then we're going to have to deal with the problem size. Now, remember, it can't be too large because that won't fit on the quantum annealer. If you look at the variables for just Delta, Delta operates 5,400 flights daily across 325 destinations. So that right there, we've already exceeded the capacity of quantum processing unit. And that doesn't even include gate assignments, crew pairings, all the variables with aircraft assignments, et cetera. So you can't put that, that's going to far exceed the quantum processing unit, but we can't also make the problem too small because, you might want to say, well, let's just focus on one airport at a time to make it smaller, more manageable. But then if you do that, you're just going to solve it using a cheap classical methods, which is not what D-Wave's out there selling anyways. And so, yes, optimization problems are everywhere in business. Alan Barrett's is right about that point. But only a small segment of optimization problems are discrete. And then only a small subsegment of those problems are big enough to warrant the cost of using D-Wave's quantum annealer. And then there's only a small subsegment of those problems are small enough to fit on the processor. And so after you do all the math and try to figure out what the total addressable market is, there's almost nothing in the real world that's actually a good fit for quantum annealing. And frankly, there's very few problems that can be solved competitively on the hybrid solver either. This isn't a technology issue. This isn't that something you're going to invest in that's going to be solved over the next couple of years with R&D. The technology is what it is. And that's why the company isn't growing. That's why proof of concepts never go to production, at least in a meaningful way. And that's why almost nobody is using D-Wave's quantum annealer to solve optimization problems. This is also, by the way, this is why they spent $500 million on a gate model computer. It's because D-Wave knows that quantum annealing has no future, and they're just trying to buy time with investors until the commercial story falls apart. So I appreciate you taking the time to learn about D-Wave's quantum annealer. We go into a lot more detail on the subject in our investment reports. Actually, Coherence is focused on providing real intelligence about the quantum computing industry, not just D-Wave, but the whole industry as well. We decipher the scientific research and then actually parse through all the clickbait hype so that you don't need to. We feel that investors need a better understanding of where the technology is going for each company and which ones are the most promising. So we've actually developed the world's first scorecards. For every company in the quantum industry, we're building detailed research reports for every major company in the space, and we're using one consistent methodology across all of them in order to bring you the best intelligence. The best part is that these scorecards are going to be free, and they are coming in July. If you'd like to learn more about companies in the space, sign up for our free newsletter at coherence.report, and please share this video in your feeds. Thank you.